Hi and welcome to a new Voltlog. This will be a follow-up video on the 300 watt pure sine wave inverter I reviewed a couple of weeks ago. If you haven't watched the review video, I will add a link in the description below. A couple of people were curious how the output MOSFETs are switching in order to obtain that nice looking sine wave on the output. If you remember, the first stage of the inverter, which is on this left side, is a boost circuit that brings the DC voltage close to 400 volts, and then we have a set of 4 MOSFETs in H-bridge configuration and a choke on the output, something like this, which follows the application example from the EG8010 ASIC datasheet. They are in fact using the ASIC module complete with these IR2110S MOSFET drivers from this example, but the output stage is from this second example, is this one right here. So I'll be using this one throughout the rest of this video. So don't take into consideration these drivers right here because they are not used in this circuit, but we have exactly the H-bridge on the output. On the upper side of the H-bridge we have 400 volts coming in, and on the bottom side of the H-bridge we have our ground connection through a 0.1 ohm shunt resistor, which gives the ASIC through this sense tab right here information about the current flowing through the bridge, and this information is used for the current limiting feature. Now I've connected the oscilloscope to the inverter so we can take a look at some waveforms. I have channel 1 connected on this point right here, and channel 2 connected on this second point. These 2 points are the outputs of our H-bridge. We can see channel 1 is switching at a frequency of about 23.4 kHz, and if we look closely we can see the signal is PWM modulated. The on time increases slightly with every cycle. Channel 2, let me just switch the triggering on channel 2. Channel 2, as we can see, is switching at a frequency of about 50 Hz. I mean exactly 50 Hz. That is what determines the frequency of the output sine wave, because channel 2 marks the point where the waveform inverts from positive to negative. And if I zoom in, we can see exactly the point where the waveform on channel 1 switches from the positive to the negative waveform. The on time becomes the off time and vice versa. The signal at channel 1 is then passed through a 3.3 millihenries choke, and the result is that pure sine wave we see at the output. It's basically a filtering going on. The choke on the output has to be sized properly in terms of output current, because it will carry the full output current. If this sounds familiar, it might be because you've taken a look at a Class D amplifier, which uses a similar PWM control method for achieving a higher efficiency while amplifying a signal. In this case, the control loop is managed by an ASIC. It's the EG8010, but this can also be done with a microcontroller. There are even people who implemented this on an Arduino. However, since the EG8010 ASIC modules are available at a good price, there is no point to reinvent the wheel. You just grab the off-the-shelf module, you design the rest of the circuit to match your specifications, and you got yourself a pure sine wave inverter. I also had a viewer ask me about the 5-volt output on the USB. Where does it get its input power, and what is the voltage ripple value? The answer is the input comes from the DC input of the inverter, so it's 12 volts, comes through this trace straight to the input of the 7805 regulator. So that's why the regulator gets hot pretty quickly, because it has to step down from 12 volts to 5 volts, and it's just hanging in free air with no heat sink. And here is how the output of this regulator looks like. We have some nasty peaks in there which go up to 200 millivolts peak to peak. This could mean that the switching noise from the output converter or even from the 400 volt boost converter is not filtered and gets back at the input of the inverter and then gets applied to the 7805 regulator. So it might be a case of improper filtering on these on one of these converters, or maybe both. So that's it for today. This was just a short video to answer some of the questions posted in the comments on the previous video. As always, there will be links in the description below to the previous video, to the inverter itself on banggood.com. So please check out those links, and I will see you next time.